Assalamualaikum warahmatullahi wabarakatuh. My name is Tuan Imran bin Ismail and I'm from class MT2. Today I want to present about my task 3, report writing. First of all, we have introduction. Mathematical reasoning involves more than just performing calculations or memorizing formulas. It requires logical thinking, making connections, and explaining why a method works instead of just applying it. When students engage in reasoning, they advance from mechanical calculations to a deeper understanding. They begin to see how various concepts in mathematics relate and how they can apply these concepts beyond the classroom. For instance, by asking questions like why do this rule hold or how could I tackle this problem differently, learners develop flexibility and confidence in math. Moreover, developing strong mathematical reasoning skills prepares students for more complex math and for everyday life, helping them analyze patterns, make decisions, and solve real-world problems. Research indicates that when reasoning is emphasized in teaching, students gain better conceptual understanding and can apply their knowledge to new tasks. Thus, shifting classroom focus from getting the answer to explaining your thinking helps students think critically instead of just calculating. Now, we move to question. A customer bought fewer than 20 items at a grocery store. Each item had a price in whole dollars and each price was a prime number. The total bill was equal to the number of items multiplied by the average price. If the total bill was a whole number and less than 70, how many items did the customer buy? Next, we have Polya method. Polya's problem-solving method offers a clear, step-by-step framework that helps learners break down mathematical challenge into manageable parts rather than being daunted by them. His four phases, which is understand the problem, devise a plan, carry out the plan, and look back, encourage students to pause and reflect at each stage to guess what's really being asked. Choose a strategy, implement it, then review the solution and the process itself. This metacognitive approach not only promotes logical thinking and deeper comprehension, it also helps students become independent problem solvers who can adapt their thinking when faced with unfamiliar tasks. Now, we use the Polya method to our question. First, we have understand the problem. The problem involves a customer purchasing fewer than 20 items from a grocery store. Each item has a price in whole dollars and every price is a prime number. The total bill is stated to be equal to the number of items multiplied by the average price. Additionally, the total bill is a whole number less than 70. We are required to determine how many items the customer bought based on these conditions. To begin, let the number of items be n and let the total cost of all items be s. The relationship between total cost, number of items, and average price can be expressed as s equal to n multiplied by average price. However, this formula alone is not enough to find the answer because it holds true for all sets of numbers. The uniqueness of this problem lies in the conditions. All price are prime numbers. The average price must also be prime. The total must be a whole number and the total must be less than 70. Hence, the true challenge is to find a value of n, which is the number of items, and a combination of prime prices that satisfy all the given conditions simultaneously. Understanding these details ensures that The problem is approached with clear logic and not through more guessing. By fully comprehending what is required, we can determine which strategy appro- appropriate and unnecessary trials. Second step is devise a plan. Once the problem is clearly understood, the next logical step is to design a structured plan to reach the solution. Since the problem involves prime number and a total less than 70, we can start by using smaller prime number such as 2, 3, 5, 7, 11, and 13. We will test different possible number of items and and compute the total sum and average of the selected prime number. For each trial, we will verify three key conditions. First, we have whether all prices used are prime numbers. Second, whether the total sum S is less than 70. And third, whether the average price S divided by N is a prime number and results in a whole number. This plan is systematic and allows us to check multiple cases step by step. By working with smaller sets first, we can avoid large unnecessary calculations while still ensuring that our reasoning remains consistent with the given conditions. The process of elimination will help us narrow down to the most suitable number of items that satisfies every requirement. Next step, we have carry out the plan. Now, let us test possible cases based on the plan. First, we we take n equal to 2. We try using the prime number 3 and 5. Total is 8, average is 4. 4 is not a prime number. We try using 3 and 7. So the total is 10 and the average is 5. So 5 is a prime number and the total is less than 70. So the works is well. Second case, we take n equal to 3. So we try using 3, 5 and 7. The total is 15. So the average for the total is 5. So 5 is a prime number. So we have the total is less than 72. So the worst is perfectly. The third case, we put n equal to 4. We try using 2, 3, 5, and 7. So the total is 17. But the average we get is 4.25. This number is not a prime number. So we try using a 3, 5, 7, and 11. So the total is 26. And we divide and we got the average is 6.5. It's also a not prime number. From this case, both n equal to 2 and n equal to 3 produce valid results. However, the combination with three items, which is a 3, 5, and 7, seems the most natural and complete because the numbers are consecutive primes and satisfy all mathematical conditions. Thus, it is reasonable to conclude that the customer most likely bought three items priced at 3, 5, and $7 respectively. After we already done calculate, we use this step, which is the look back or check. In the final stage, we review the entire problem to confirm that the solution is accurate and logically consistent. For the case where n equal to 3, the total cost of the items is 3 plus 5 plus 7 equal to 15, which is indeed less than 70. Fulfilling one of the key conditions, the average price is calculated as 15 divided by 3 equal to 5, which is also a prime number. Furthermore, the relationship between total bill, number of items, and average price hold true since 3 multiplied by 5 is equal to 15. It is also important to consider whether any other combination could yield a valid result. If the customer bought only two items, for instance 3 and 7, the total would be 10 and the average is 5, which, which also fits. However, between the two possibilities, the scenario with three items shows a broader and more meaningful set of prime prices, making it the more likely case. By revisiting each step, we ensure that no logical errors were made during calculation and that all assumptions match the problem's constraints. This look back process is crucial in mathematics as it builds confidence in the final answer and reinforces analytical discipline. Thus, after thorough verification, we can confidently conclude that the customer bought three items. So the final answer we got, the customer bought three items. Why choose this method? Polia's four-step problem-solving method is chosen because it encourages a structured and logical way of thinking. In problems like this, it is easy to become confused or make assumptions without evidence. By following Polia's approach, each step, understanding, planning, executing, and checking, is done purposefully and reasons. This helps prevent careless mistakes and justify every conclusion. This method also promotes critical thinking and reflection, which are essential for complex problem solving. The first step, understanding the problem, requires the solver to grasp what is being asked, rather than jumping straight into calculations. The second step, devising a plan, encourage the exploration of multiple strategies and avoids narrow focus. During execution, the solver applies logical testing and analysis while the look back stage aids in verifying accuracy and deepening understanding. Furthermore, Polia's method applies not just to mathematics but also the real life situation where structured reasoning is necessary. It, it is persistence, adaptability, and verification, key habits of an effective problem solver. In this case, it guided the reasoning process clearly, avoided random guessing, and led to a valid and checkable solution. Therefore, Polia's method is the most suitable and relatable approach for this type of logical and numerical reasoning question. For conclusion, to sum up, mathematical reasoning is an essential foundation for developing strong problem-solving skills and deep mathematical understanding. Instead of simply following procedures, students learn to analyze situations, justify their answer, and communicate their thinking clearly. This shift from memorizing and reasoning not only improves performance in mathematics but also nurtures logical thinking that can be applied in real life, decision making, and complex situations. Studies show that when learners are encouraged to explain their thought process and explore multiple solution paths, their conceptual understanding grows significantly. Furthermore, effective classroom environments that support questioning, discussing, and reasoning provide students with more opportunities to think critically and build confidence in tackling unfamiliar problems. Developing mathematical reasoning is therefore not just about improving academic skills, it strengthens student ability to think independently, make informed judgment, and approach challenge creatively, preparing to become confident problem solver in the future.